Right. Now that more of you are here, although not all of you are here yet, who are we still waiting for? Hazza, Aziz. Yeah, they were all with Sylvia. Okay. So, are you ready there, guys? Yeah. Do you all watch episode 1 and 2 of Rick and Morty yet? What? Oh, I knew you were a bit strange. Episode 1 or 2? The season 4. Yeah. Oh, the Death Crystal. Yeah. That was funny. Episode 2 is all about Rick's toilet.
Oh my god, I actually don't watch that.
Yeah. Yeah. He has a secret toilet planet.
Rick and Morty!
You watch it too? No.
It's great.
Awesome.
What?
That was awesome though. You have to try it.
It is a good show. It is a good show. Now, here we go. Is this everybody?
No.
Who's left? Just Rotimi?
Yeah.
Okay. He's not too disruptive. He's not in today. Yeah. Okay, so the first question that was asked, and it was asked in the last tutorial as well, is exactly what is the difference between an inflection point and a saddle point? Now there's a very small difference, but firstly let us check that you're all clear. What is the definition of an inflection point? Oh, you just need to change the word both. It's not quite right. Yeah, when it what can we say? Transfers, yeah, from being concave to convex. Okay, so if we were to draw it, it would look something like this. Oh, I'm sorry, can't you see it when the TV's off? I think my favorite episode is Pickle Rick.
Oh, like the John Wick type of pickle.
It's a classic. It's a classic episode. Right. And Obama was a good one too, yeah. Now, what is the definition of a saddle point? Yeah, can we give it a sentence? Yeah, good. It's between max and min, isn't it? Yeah. Yes, I like this. It's a turning point. It's a turning point between concave and convex. And we call it a saddle point because just like a saddle, you can't tell if you're at the max and the min. So, a saddle point is like this. Now, if you look at this, there's not a huge difference, but who can see what the difference is? Yeah, what is the precise difference? Yeah, well, the gradient, its values. What are you saying is the difference? Yeah, or more precisely, we could say it's simply not 0. And here, it is 0. Now, I want you to listen carefully. Oh, who's this now? Oh, Ray. Ah, how could you forget about Ray?
No worries, I know that.
Okay. Everyone is here.
Yeah.
Great. So, I want you to listen. Everybody I like is here. I wonder if you'll watch this later. If you're watching this, Barack, please comment. Yeah. Right. So listen carefully to my definition. An inflection point is when the graph switches between concave and convex. A saddle point is a turning point and also a point of switching between concave and convex. Now, if you have those definitions in your mind, is it true or false to say an inflection point is also a saddle point? That's false.
Not always.
Yeah. But is a saddle point an inflection point?
Yes.
Yeah. Because to be an inflection point, you just need to switch between being concave and convex. But to be a saddle point, you need to both switch, because you can't tell if it's a max or a min, and you need to be a turning point. So this means all saddle points are also inflection points. In maths, we say that the saddle point is a stronger condition. You need more things to be a saddle point, but an inflection point is a weaker condition. So all saddle points are also inflection points. Okay. Amy, you were asking me this, so does that clear it up in your mind a bit more, the difference between the two, or not? Yeah, it's okay? Yeah. So if I'm being technical, I could say, maybe if you want, you could call it an inflection saddle point, but that's a little bit over the top, because it's always going to be an inflection point. Right, okay, so that difference is cleared up, I hope. What question do we want to see first? Yeah, which page?
76.
No, I saw Hazza first. Can you put your hand up, Hazza? Good. And then I'll get to yours next.
Page 76.
Go on, yeah. Which one?
1B.
Yeah, now the answer for 1B is wrong, but I would like to do it to make sure that I said in class the answer should be concave. But let's confirm that, okay? So, we have y equals 4x4 minus 84x cubed. Oh no, sorry, that's the wrong one. 1b on 76. Y equals minus 4x cubed plus 6x squared minus 8x plus 27, and x is equal to 2. Right, so step 1, differentiate and evaluate. So dy dx equals minus 12x squared, correct?
Yeah.
Plus 12x minus 8, and we put x equal to 2, and does anyone have this value for me? Minus 32.
Yes.
Okay, so according to my flow chart, I now turn right. Differentiate and evaluate again. That's equal to minus 24x plus 12. X is equal to 2.
Minus 36.
Minus 36, so that's negative. So yes, quite clearly, fallen and concave should be the answer.
So when we do this, like this process, we have to stop in some point.
Yeah, this flow chart doesn't continue forever. Yeah.
If we got 0 at the first,
Yeah.
we have to do it again, right?
Yeah, you can see in the flow chart there's this piece here that loops around. So if you get to the end and you get 0 again, you go back up a step and differentiate again. In other words, there's a loop here where you keep differentiating until you don't get 0, if you were getting 0. You know?
So we kind of from the first answer is negative 32. It's less than 0.
Yeah, so that means it's fallen. It's going down.
Yeah.
And then the second derivative being negative tells us it's concave. So the graph at 2 looks like this.
But you mentioned at the beginning if it's like the differentiate is less than 0,
Yeah,
it's gonna be concave.
if the second derivative is less than 0, it'll be concave. If the first derivative is less than 0, that just tells us it's a downward graph. It's falling, like in this picture.
Yeah. Okay.
Yeah, can you see okay there? Are you sure?
Yeah,
You can't, can you?
Yeah, I can.
Alright, if you say so. Hey guys. Do you have a question? Yeah?
No, I'm just counting.
Is he helping you with your counting? Are you a little bit shaky on your counting? What are you counting? Okay. 1, 2, 3 is okay, but after that it starts getting harder. Yeah, okay, yeah. The hard part kicks in, yeah. Alright, What do we need to see next? Yep. Yeah, fine. Yeah.
Same question?
No.
Page 78,
Yeah, which one?
number 8.
Yeah. Students had that one yesterday as well. Let's have a look at that in a moment.
The answer in the book is wrong, right?
Yeah, it should say fallen and concave. Yeah. You know, when you make 2,000 maths questions, one or two of them might be wrong.
Yeah.
One per 1,000 maybe. Right, do you have that now? Yep. So, I'll get to that one in a second, but I said you can be next if you had a question. Which one was it?
76.
Yeah.
Question 2.
Two, which one? Will I do like A or something?
Yeah.
Yeah, okay. So 2A on the same page. Oh, my head. Ukrainian is an interesting language. It almost sounds like your mouth is full of crackers.
Oh my
Right.
God. Wow. Fast word today. Wow.
Sorry, I'm very tired. It's been a very long week. I'm just looking forward to the weekend. And this is my last class today, so I'm energized. Yeah.
Speak some Ukrainian?
Huh?
Want to speak some Ukrainian?
Not on a Friday. Yeah. Maybe on a Tuesday. Yeah. All right. So, what do I do first here?
Put the 4 down. It's gonna be
Yes, very good. Very good. Put the 4 down. Okay. Now, what's dy dx here? 4 over x plus 4x minus 8. Now, we're looking for the stationary points. So, next, equal 0. Okay? There's something I can do to simplify this.
divide.
Yeah.
Not quite, but before that.
Divide by 4 and
Divide by 4,
multiply by.
and then multiply by x.
Yep.
So this becomes 1, x squared and 2x. So if we look at this quadratic, I think this has only one solution, right? X minus 1 equals 0. So x equals 1. And y would equal minus 8? No, yeah. Yeah, minus 8. If you sub 1 back in to here, okay, on the calculator you should get minus 8, I hope. Is that okay so far? Now, do we know anything about this stationary point? Do we know it's a max or a min or even a saddle point? We don't know. So what's next? Second derivative. So, do you remember what the derivative of 4 over x is? And the derivative of 4? Actually, do you know what? I'm going to write this as a power. Minus 4x power minus 2. Plus 4. Now, what happens if we put in x is 1? We get 0. So, do we know if it's a max, min, or saddle?
No.
No. So, next job? Third derivative. Okay, what do we get now? And when I put x equal 1?
We get negative.
Positive. 8. So, if the third derivative is positive, that makes it a rising saddle? Isn't that right? Yeah. So, this is a rising saddle point.
Can you repeat the step where multiplied by x?
Yeah. You mean here?
Yeah.
So I multiply everything in it by x. So if I put in red, okay, it's like I put an x here, an x here, and an x here. So if I have x and 1 over x, what happens?
Cancel.
Cancel. So that's why I get the 1. x times x, that's why I get the x squared. And 2 times x, that's why I get the 2x. And 0 times x is still 0. Yeah, is that okay, Hazard?
Then we differentiate again.
All I did on the next step was just put the x squared in the front. I just cleaned it up a little bit. Put the 1 at the back and the 2 in the middle. You look very confused. It's here to hear confusing.
Just
Yeah.
change
The order.
the order.
Yeah, it's like if I just said A plus B plus C, I'm allowed to say that C plus
So
B
when you
plus A.
factorize,
Oh,
you
okay,
get
okay.
confused.
Yes, I'm trying to prevent confusion. It seems like I caused some confusion. This is just cleaner.
Yeah,
Yeah.
but why didn't we just like have a second derivative without factorizing or anything?
Because we need to find the value of x. Because otherwise we wouldn't know what value of x to use. It's not provided in question 2. It was in question 1. You know. Okay, so in a moment, Alex, I'll do that question on the next page, number.
8.
Not the next page. Which page?
78, sorry.
78, number.
Number 8.
Oh, number 8. Oh, good. The students yesterday didn't ask me about that one. I was looking at number 5. Yeah, number 8 on 78 in a moment. Please write this down. Oh, what's wrong, Hazard? Tell me.
Why there's in the second derivative there's minus 2x power?
Yeah, because if you look here, here, 4 over x is the same as 4x power. What is it? 4 over x is 4x power minus 1. If you bring the power down, 4 times minus 1, minus 4. And then minus 1 from the power. It's using rules of power and the derivative rule was used. Yeah.
Then we substitute the 1.
Correct.
Because-
Yeah, correct, yeah.
And
We got 0, so now we need the third derivative now.
then we got 8.
8, so we're finished.
Yeah.
Yeah.
Oh.
Yeah.
Okay.
Okay, yeah, Grant, yeah, write that down. Okay, do you all have that? How's it?
So 4 over x is like the derivative of it is 4x minus 1.
Before the derivative of it is 4x minus 1, and then the derivative becomes 4x minus 2. The rule is you bring the power down and you minus 1 on the power. Yeah? Can I go on to the next example? On page 78, number 8 now? Yeah. Now, goodness, I can't quite remember. No. I'm trying to remember if this was an exam question. I don't think it was an exam question, but it is something that I could see in the exam because it uses. No, well, I don't know.
50-50 chance.
Maybe even less than that. Yeah. But anyways, it's a good practice question. So, a car is 50 metres from the centre of a crossroad and heading north. No, sorry, from the north. So let's draw this picture.
It's heading south.
It's heading south, yeah. So here's the car. It's 50 meters away, and it's heading south. And do I give the speed it's going at? 10 meters per second. Another car at the same time is 84 meters from the crossroads, heading towards it with a speed of 14 from the east. What did I say? 84 meters. And the speed is
14.
meters per second. Okay. Before I begin, can anyone tell me, will these two cars collide?
No.
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 No,
Because-
No.
You need to take a second. Why not?
Because the first one takes 5 seconds to reach the crossroad, the other one takes 6 seconds.
Yeah, the first one will take 5 seconds to get the crossroad. The second one will take 6 seconds to get there. Yeah. So by the time the first one is at the crossroads, the other car is still 1 second away. And then after it passes the crossroads, a second later, the other car is now at the crossroads. So they don't meet. Are they getting closer together? Yeah. Do they meet? No. Later will they get further apart?
Yes.
Yeah. So then, therefore, if they're far apart at the beginning and far apart later, there must be some point in the journey where they are closest. Logically. At the beginning, they're far apart. Much later, they're far apart. At the beginning, they're getting closer. Later, they're getting further apart. Logically, there has to be some point where they are closest to each other. Where is that point? You could make some guesses. You could say, maybe it's when the first car was at the crossroads. Maybe it's when the second car was at the crossroads. Or maybe some other point. Okay? So, we begin by using Pythagoras' theorem to find a formula for the square of the distance. That is, this has separated a distance d, but I would like to know the square of the distance. So, this seems perfect for Pythagoras. However, we need to know what this distance is. Now, it might seem like it's 50, but that depends on how much time it's passed. For example, at the beginning it's 50, but 1 second later, what is it?
It's 40.
It's 40. Why?
Because
The car moved 10.
yeah,
2 seconds later, what is it?
30.
30. 5 seconds later, what is it?
Increasing, not increasing.
What is it now?
0.
50. Sorry, I jumped back in time. What is it now? 50.
Yeah.
Which way is the car going?
So,
And after 1 second, do we have more distance or less distance? Are you sure?
50 from the crossroad.
It's going to be 40. Yeah? Yeah. Alright, so after 5 seconds, what's the distance? 0. It's at the crossroads. Can we write a formula down in terms of t for how far it is from the crossroads?
T equals distance.
No, not... Well, yeah, but give me the final answer. You could guess it. It starts at 50, then it becomes 40, and then
minus
30. What is it?
10.
Yeah, so give it to me as a formula. 50 minus 10t.
Yes.
Right?
Mhm.
When t is 0, we get 50. When t is 1, we get...
40.
When t is 2, we get 30, and so on. Right? So by using the same logic, what's the distance here?
84 minus 14. T.
And by using Pythagoras, d squared will equal 50 minus 10t
Squared plus 84.
squared. Okay, I'll let you write that much down and then we'll continue. Did anybody get that? Okay, well,
Close.
write that down. Close, okay. Because in a moment I'll have to go to the side to explain a different point. square root. Well, this is what I need to talk about. We got that? Okay. Can I scroll to the side? Yes? So, let me show you a table here. What I'm going to put as an example, here are different times. Here are different times, and here are different values of y, we'll say. So let's just say 0, 1, 2, 3, 4. So, I don't know, let's say this is 2, 3, 4, 3, 2. For what value of t will y be maximum?
2.
2. Fair enough? Okay. Now let's look at y squared. Y squared. 4, 9, 16, 9, 4. For what value of t will y squared be maximum?
2.
2. Can you see that by squaring the y, we did not change the answer to the question, where will this be maximum? Now, we did change what the maximum is. Originally, the maximum value was 4, and in the second case, it's now 16. But did the maximum occur at the same location?
Yes.
Yeah. Question? Or?
What is y?
Oh, it's not important, the values, just some function. And these are some values I've given you. The point I'm trying to make, huh? Just example, yeah. The point I'm trying to make is, if I ask you, where is blank a maximum, or where is blank squared a maximum, or a minimum, that's the same place. Okay? That's useful, because if I ask you, when is the distance minimum, that can be answered by the same question, when is the distance squared a minimum? And this saves me the trouble of taking the square root. Replay that. Left click, rewind 5 seconds. Yeah?
We're not making square root.
Exactly.
We are
So
getting as a result like
the t.
the t. Like
Yeah. So just to repeat that, okay? The question, when is the distance d minimum, has the same answer as the question, when is the distance squared minimum?
Because of the y example.
Yes. Thus removing the need to square root. It's a nice little trick to make our lives much easier here. So I don't need the square root, although I still need to expand. But at least I don't have to expand and square root. So I've cut my work in more than half. Because you haven't learned actually how to differentiate a square root quadratic. You've only learned how to differentiate a quadratic. We haven't done square root quadratics. And maybe Ray might know what rule would be needed in semester 2 for square root quadratics.
Oh yeah.
Yeah?
Yeah.
What rule?
Square root quadratic.
Would need what rule?
You mean integration? Wait.
Differentiation.
Square root
Quadratic.
for here.
Yes.
Just wait.
Chain rule.
Oh, chain.
Yes, chain rule. Yes, yeah, yeah.
Oh, chain substitution.
Yes. Yeah. Yes.
We don't need to use that.
I know, that's my point. I've saved the trouble of doing this
Oh.
by not square rooting.
Okay.
But I still need to expand. So with your help, please, what do we get when we expand? That will be 2500
Yeah.
minus 1000 t plus 100 t squared. Oh, what's 84 squared, please?
Something.
Oh, it certainly is. 7056. And then 28 times 84? 2352 t. And 14 squared? 196. So d squared is oh, sorry. Yeah, sorry. T squared. Is 296 t squared. Yeah? Minus 3352 t. Yeah? Plus 9556. Actually, I don't care about that because as soon as I differentiate it, it's gone. Yeah. So, what is the derivative of b squared?
2D.
Yeah, so this one, the quadratic here. So, 592 t minus 3352. And that should equal 0. So, we have found when the distance squared is minimum, and hence the distance, it will be at this time. Can someone give me... Yeah, how many seconds is that? A few seconds only.
5.66.
5,196 seconds. Is it possible you did something wrong there? 5.66. Okay. Now, what I would like to do is draw the picture at this moment. Tell me this. The first car, is it in the north or the south of the road?
No.
South.
South. Why?
Because it's more than 5 seconds.
It's more than 5 seconds. It took 5 seconds to get to the crossroads. So the north car, the car from the north must be somewhere here now.
0.66 seconds.
0.66 seconds after the crossroad intersection. And the car coming from the east, will it be on the east or the west?
To the east.
To the
Just
east.
about to cross.
Just about. Less than a second away.
Yes.
Let's get these two distances. So can someone do maybe Karul, could you do 50 minus 10 times 5.66? And maybe you could do 84 minus 14 times 5.66. Now your answer should be negative to indicate that it's in the south.
And yours is positive.
What did you get?
Minus
6.6 meters from the crossroads. And then this distance?
Still calculate.
4.76 meters. Therefore, Pythagoras gives us this shortest distance. So, Amy, could you type in the shortest distance here on Pythagoras, please? I'm hoping you get something like 8.14 meters, roughly. Don't worry.
Yeah, 8.94.
Okay. Yeah.
But we didn't use substitutes.
I know. Wasn't it great? We didn't need to use substitution.
Well, why you asked me?
Because 2 weeks ago you were going on and on and on about product rule, quotient rule, and chain rule.
Oh.
So I wanted to know if you knew which of the three you would need to use here if I didn't use my trick.
Sorry, I didn't get
Okay.
it.
Just you know what? Just pretend I never asked you anything. Just be-
But we actually we don't need to do that because
Egg.
that makes more complicated.
That's what I.
If I
That was my point.
You
Yeah,
start
yeah,
straight
yeah.
all the time.
Yes, yeah.
We square
Yes.
it down, and then after you have to calculate twice.
That's
You
all
don't
I
need to
wanted.
do that.
That's all I wanted you to realise.
I'm sleepy,
That's,
so I don't
that's
want
fine.
to do
That's
too much
fine.
work, man. I'm sleepy. I don't want to do work.
I understand this
I don't
feeling.
want to do work.
I understand this
Yeah,
feeling. All right.
yeah.
What do we need to see next? We've got a bit of time. We can do another question. Yeah.
Okay. Page 70.
Yeah.
Q
Oh.
and
Which one?
Q.
Yeah, but
What?
which? Q and T.
Yeah.
Q. Are you sure?
From which question?
Page 70.
No. P.
Okay. P. That makes more sense.
Yeah.
Okay.
What's
You mixed up your P and your Q, did you? Yeah. Right, page 70P. Can I scroll down, Haza?
Question 1, 2.
1P. Sorry, 1P, sorry. So look, you have y equals 4 over x power 5. What should you do first before you differentiate?
Bring the x.
Bring the x above.
And what will it become?
Minus 1.
Minus 5. Now you can differentiate. So you bring the 5 down, what do you get?
Negative 20.
And the power becomes
Negative 6.
No,
Six.
-6.
minus 6. Good. And this can be written as minus 20 over x power
6.
6.
Why isn't minus 5?
Why isn't it what?
Minus 5.
What's minus 5 minus 1?
Minus 6.
Yeah. That's all right.
You're sleepy, bro, right? I know you're sleepy, man. Don't worry, don't worry.
No,
I'm
don't,
so sleepy, man.
don't believe me. Don't believe me. Check it. Check it. I see. I haven't earned all of your trust yet, so I'll need to work on that a bit more.
Oh, okay.
Yeah, that's correct.
Thank you for confirming that.
We all had our suspicions.
It's good to always be a bit suspicious of your teacher. Just make sure they're telling the truth. You know? Yeah.
What about T?
T. Let's see. What's happening in T? Yeah. Okay. Good. Let's do T. That's a little tricky. Yeah. Actually, can I just give you a few seconds just to try T, just to make sure you got it? It's a little tricky. Just give you a few seconds to try T there.
Which page?
70.
Question
1 T. Yeah.
Interesting question.
Yeah. Give it a try.
Just T, what's wrong?
Page 70. 1 T.
Yeah.
What's the answer?
9 seconds squared minus 2.5 T.
9 seconds.
Wrong
Seconds.
Seconds.
This is what we're
What
doing.
question are you looking? Yeah. Thank you.
A 2 or
Here.
oh, what? Okay. Oh, sorry. I'm wrong now. Okay. No.
Have we-
I'm sleeping.
Yeah, no, that's
Guilty.
clear.
I'm
That's
guilty
clear.
now,
Yeah,
man.
yeah,
I'm
that's
so
it.
guilty. Oh, okay.
All right. You got it.
Got it.
Yep. So this one
It's a negative answer.
there has a minus in it. Yeah. So look, guys, look up.
Okay.
No,
It has to be 1
no. That's wrong.
Yeah. It's very important that you simplify this before you begin differentiating by using the rules of logs.
Yeah.
So which rule of log do I use first?
Minus.
The minus one.
Yeah.
This is log 3 minus log x squared. This is rule number 2 of logs. And then using rule number 4, I think, what do I do next? Bring the 2 down.
Yes.
Yeah.
This is rule 4 or something. Now we can differentiate. Ray, look up, please. Now we can differentiate. Log 3 has a derivative of 0 because
Constant, man.
it's a constant.
Yes.
And the derivative of log x, do you remember?
Minus 2 over
Minus
x.
2
Yeah, well, minus 2 times 1 over x, which of course is minus 2 over x.
Yeah.
That's the answer then.
What? It's so
No,
You're sleepy as well, right?
you can't be saying yes as I'm teaching it and then at the end go,
What?
Right.
Yeah.
Wait, so
yeah.
can you just bring the x up and then it becomes -2, x to the power -2, and then you have to bring it down?
You can't bring the minus 2 out while the 3 is still there.
Okay.
Yeah. So technically you can't, you could only do that if there was a minus 2 also on the 3. Yeah. Okay, have you got that written down? Yeah. Okay. How are we doing? Yeah, we'll get one more
How
question
do you
done.
get B minus 2? From log?
I brought the 2 down from the power. This is using, I think, rule 4 of logs.
There is no power.
This power. Yeah?
No, I mean the second one.
Oh, here!
Yeah.
Ah, yeah, well, that's because the rule that says the derivative of log x is 1 over x.
Yeah.
Oh, yeah.
And the rule of log 3.
Yeah, it's a constant. There's no x in it.
We're differentiating.
It's gone.
No, the minus 2, I mean. -2, yeah, that one.
Yeah?
From where?
There, right there, that's minus 2.
Right there.
One square.
And what about the log 3?
Log
You
3.
just asked me. It's gone because it's a constant. Constants
Oh,
differentiate to 0.
Okay. Yeah.
Yeah.
Because this one is constant, So,
Yes?
uh,
Yes? 72, which one?
26.
Do you think the answer's wrong, or?
No.
Okay, well, what confused you in it then?
Which question?
26 and 72.
26.
Yeah.
Yeah, I think,
Yeah.
I remember.
Is another name for stationary point. Okay, fine. Yeah. Which one?
Can I do 78, 5?
Yeah, 5. 78, 5. We'll finish on this one. So, now please guys, watch carefully because this one is a little bit tricky. Okay? So the question is, express the number 8 as a sum of two numbers such that the result of multiplying their product by their difference is a max. So, let me give you an example of what's happening here. You need to think of a way to write 8 as the sum of two numbers, for example, let's say 1 plus 7 or whatever, yeah, so that when you multiply their product by their difference, you get a max. What is the product of 1 and 7? That is, what is 1 times 7? 7. And what's the difference? 6. So 7 times 6 is 42. Let's take another example. Like you said, 3 and 5. What is their difference? 2. And their product? 15. And 2 times 15? 30. And one more example. What about if we said 8 is 0 plus 8? What is their product? And their difference? And 0 times 8? Okay, so we know it's not going to be out at the extreme. There must be some value in between, like maybe around about 4 and 4, but it's not going to be 4 and 4 because their product 16. Their product is 16, and their difference 16 times. Yeah. So maybe somewhere, I don't know, somewhere around about between 1 and 3, maybe 2, 2.1, who knows? There must be some maximum. So the problem here is we need to express this as an algebra problem. So this is what we're doing. We're saying that 8 equals x plus y, part 1. Part 2, we're saying that we would like the maximum value of their product, which is xy, times their difference, which is x minus y. We should give this a letter. We can't keep calling it the multiplication of their product and difference. So we'll just call it z. So what is our goal? Our goal is to find the x and y that will make a max z. Okay. What is currently the problem with z? What is the complication with z? We can open the bracket, so that's not really a complication, but there's a bigger problem with z. The big problem with z is it has two variables. Yeah.
Yeah, we don't have another way.
Yeah, so we can fix this. How?
Substitution?
Yeah. If we sub this in here, we can reduce it to one variable problem.
Yep.
So let's replace the x. Okay? So z will equal x. What's x?
8 minus y.
Times y. And then x minus y. So what's x? 8 minus y minus y. Okay. Now let us expand. So we get z equals 8y minus y squared times 8 minus 2y. When I expand, what type of equation will I get? Try again. 64y minus 16y squared. Isn't it this 8y times that, right?
Yeah.
Minus 8y squared plus 2y cubed. So z equals 2y cubed minus 24y squared plus 64y. Now, how do I find the value of y which makes z a maximum?
This is 0.
differentiate. So dz dy equals 6y squared minus 48y
plus 64.
64 equals 0. Now, this equation, I'll tell you... Oh, hang on, sorry, what page are we? Oh, sorry.
Question 5.
Yeah. This equation, I'll tell you now, doesn't have factors. You'll need to use the quadratic formula. And you'll get y equals 1.69, or you'll get y equals 6.31 after you use the calculator. And then how can we get the corresponding x values? Sub it back into this one. So the x that goes with this one is 6.31, and then when you sub in 6.31 you get 1.69. So it looks like we have two answers, but we really don't, because you're saying the first one, x plus y, is this. That's our first possible answer for 8. 8 equals 6.31 plus 1.69. Or, what's this other answer we're saying? It's the same thing, isn't it?
Yeah.
So it's redundant. So the way to express 8 as a sum of two numbers so that multiplying their product and difference is a maximum is as follows. You say 8 is 6.31 plus 1.69. If you calculate the product of the multiplication and the difference, you'll find that you'll get a number bigger than 42 or 30 or anything else I could guess. Okay. This is a hard one. This is for sure a hard one.
We just go from the back.
Huh?
We just go from the back. We know that we need 8 as a result.
Yeah.
So we're trying to get.
Yeah. I mentioned this yesterday in the class. There's a term for this equation. It's a little bit like the equation when we said, remember when we said the can of Coke or the can of whatever, coffee or whatever. We said the volume equals pi r squared h. Do you remember this?
Yeah.
And we got from this formula the h, and we subbed it in to the area volume. Do you remember it? Remember it? These two equations here have a special name in these problems. Does anyone know? The example is 8 equals x plus y. These are called, now listen carefully, these are called constraint equations, because in both examples they represent a constraint on your freedom to choose values. For example, can we choose any value of x and y as an answer?
No.
No. We have to make sure the x plus y gives us
8.
8. Can we choose any radius or height for our coffee cup?
No.
No. We have to choose a height and radius to make sure we get a volume of 330. Okay? These are called constraint equations. They restrict what potential answers we have for making maximums or minimums. There's a little bit of vocabulary for you. Okay? So yeah, this is a difficult topic. Now, is this on every exam? No. Like I said, it's a 50-50. The exam question on calculus will either be an optimization problem on page 78, or, what's the other possibility I said? A general derivative test on page 76. What did I just say? The calculus question in the exam is usually either page 76 or page 78. Which would you prefer it to be? Both. I think I would too. Anyone else? Straightforward, isn't it? It is much less work. Alright, we'll wrap it up there. No. YouTube.